Alright, let's continue on. Next we're going to discuss the triangle proportionality theorem converse. That states that a line through a triangle is parallel to one side of the triangle if it divides the other two sides of the triangle proportionately. So this is just the exact opposite of the theorem that we just covered. So, for example, if I were to give you this triangle, QSU, and it's got a line cutting through it, line RT, and I were to tell you that this proportion is true, could you prove that that line RT is actually parallel to line QU? So I've gone ahead and prepared a proportion over here on the left that follows what we established over there on the right. I've plugged in the numbers. Side RS having a length of 9 and QR having a length of 27, and side ST having length of 5 and TU having length of 15. Now you would just cross multiply here and make sure that they're actually equal to each other. So 9 times 15 is 135, and 5 times 27 is also 135. Now because this proportion is equal to itself, that means it's true. And if it's true, that means that line RT and QU are actually parallel to each other, proving the triangle proportionality theorem converse for this problem. Now remember, you only could have used that converse theorem if this proportion that you had set up came out to be true, and it did because 135 is truly equal to 135, which means that these two lines, QU and RT, must be parallel to each other. Let's go ahead and move on now. Now I just want to discuss some simple ratios with you. Let's begin with the perimeter ratio. The perimeter ratio just suggests that when you're comparing two similar triangles, you can establish a proportion or a ratio. So in this case, the perimeter of triangle ABC is proportionate to the perimeter of triangle XYZ, because they're similar triangles. Now that only works if you already know that the triangles are similar. Or you can use this perimeter ratio to establish similarity. If all three sides creating the perimeter are similar from one triangle to the next, then those two triangles are similar to each other if those sides are proportionate. So let me show you how we would compare these two perimeters. First, we would add up the perimeter of triangle ABC. And if you add up the perimeter of triangle ABC, you'll find that it equals 30. Next, you could add up the perimeter of triangle XYZ, and that adds up to be 90. So, if we just reduce that ratio, it reduces to a ratio of 1/3, meaning the similarity, the proportion of the triangle ABC to triangle XYZ is that it is 1/3 the size of XYZ. Now let's take a look at an area ratio. So you can also compare the area of triangle ABC to the area of triangle XYZ. If you were to solve for the area of triangle ABC using the area formula for a triangle, which is 1/2 base times height, you'd find that the triangle area for ABC is 30. And you could apply that same principle to triangle XYZ, and you'd find that it has an area of 270, meaning the ratio of the areas of triangle ABC to XYZ is actually 1:9. So, if you know the perimeter ratio of one set of triangles, like you knew that this was 1/3, one way to solve for the area that will always work when comparing two similar triangles is to just take that perimeter ratio and square it. And that would be the ratio of the two areas. So, for example, 1 squared is 1 over 3 squared, which is 9. And you arrive at the same area ratio as if you had done all the work to calculate it out. So knowing what you now know about perimeter and area, let's take a look at an example problem. In this problem, I'd like you to solve for the area and perimeter of these two triangles. Now, I can tell you automatically that these two triangles are similar. One way that I could say that is because of the angle-angle similarity that you've just learned. You know that this angle, angle B, is proportionate to angle D. They're both 90-degree angles. And by vertical angles, these two angles are proportionate to each other as well, which means that triangle ABC must be proportional to triangle EDC. So I'll write that here. Triangle ABC is proportionate to triangle EDC. And now we can use that to solve for the missing pieces. For example, let's set up the proportion. Let's begin with two known values. We know that BC has a length of 4, and that corresponds to DC on triangle EDC, and DC has a length of 8. So the proportion of triangle ABC to triangle EDC is really 1 over 2. Because we know that they're similar via the angle-angle theorem, we know that that proportion applies to all of the side lengths. So, if this side length AC has a value of 5, that's going to be proportional to this missing side length, CE, because it's the hypotenuse of the other triangle, EDC. And that's equal to the proportion still of 1 over 2. So we'll just cross multiply. 5 times 2 is 10, and that's equal to 1 times x. So, side length CE has a value of 10. Now we want to solve for the area and perimeter of these two triangles, which we can now that we know the missing side lengths. Let's start with triangle ABC. To calculate the area of that triangle, so area of this triangle is equal to 1/2 times base times height. And the base of that triangle is 4, while the height of it is 3. 4 times 3 is 12, and half of 12 is 6. So the area of triangle A, B, C is equal to 6. So remember what we said earlier, that the ratio of areas is actually the proportion that belongs to these two triangles, 1/2, squared. So the area proportion is actually 1 squared, which is 1, over 2 squared, which is 4. This is the proportion we could use to calculate the area in relation to triangle ABC and triangle EDC. So if the area of triangle ABC is 6, and we don't know the area of triangle EDC, but we know that they belong to a proportion of 1 over 4, then we can just cross multiply. And we can get 1 times z, which is z, is equal to 6 times 4, which is 24. So the area of triangle EDC is actually 24. Now if you were to just check it by doing 1/2 base times height, well, the base is 8 and the height is 6. 8 times 6 is 48, and half of that is 24, so it still works out. You could do it that way, or you could use the proportion that we know. Now the perimeter is just going to be proportionate to the side length proportion that works to make these two triangles similar, 1/2. So if the perimeter of triangle ABC is 12, then the perimeter of triangle EDC can be solved by just setting that proportion equal to the proportion that we know for these two triangles. So cross multiply, p times 1 is p, and 12 times 2 is 24. So the perimeter of triangle EDC has a value of 24. And yes, you could have just added those three side lengths, 6, 8, and 10 together. This is just one other way to solve for this.